Our last kinematics example, we're going to look at how we can identify where an object changes directions and then also the distance travelled for the first 10 seconds. So to do that, we need to find the velocity function, which is s dashed of t. This one comes out to be 2t take 3. For us to change directions, our velocity must be equal to 0. So we end up with a result for t being 1.5 seconds. To find the location or where that object changes directions, we can substitute 1.5 into our original displacement function. And substituting that in, that would give us a result of negative 12.25 meters. So we can check that by using our technology. So our graphics calculator, the image of the displacement function, our gsolve min gives us our y coordinate of negative 12.25. That corresponds to the displacement at that time interval. Part B of the question, we're looking to find the distance in the first 10 seconds. So we need to look at the first second and a half where we would be travelling to the left, and then the next 8.5 seconds to the 10-second mark. So we substitute s of 0, s of 3 over 2, which we previously calculated, and then s of 10. S of 0 would be minus 10 from our function, and s of 10, if we use our calculator, trace 10, we get a y coordinate of 60. So the distance that we've travelled, we've started at negative 10, gone back to negative 12.5, and then headed to plus 60, means we need to add these two intervals together. So 60 take negative 12.25 is for that last 8.5 seconds, means we would have travelled a total distance of 72.25 meters. And in the first second and a half, we're going to go ahead and do negative 10 take negative 12.25. And the reason we change the order is so that it becomes a positive. Alternatively, you could have used modulus symbols here, and that's obviously 2.25 meters in the first second and a half. So the total distance is going to be 72.25 plus our 2.25, giving us 74.5 meters travelled in that first 10 seconds. Part C, for what values of t is the speed decreasing in this case. So we want our sign diagrams of v of t and a of t to be opposite. Our speed previously we looked at increasing is when the signs are the same. So we've found v of t already, which was 2t plus 3. That would give us a sign diagram from t equals 0 at 1.5. Our velocity function was going to be negative into a positive. To identify the a of t function, we need to derive v of t, which is a single value of 2, which is always positive. So there is no key value on there. So for our object to be decreasing in speed, we want our signs to be opposite. Previously increasing, it was when they were the same sign. So object is decreasing for the time interval of 0 to 1.5 seconds. Again, opposite signs result in a decreasing speed.